Hello, everyone.
Hello.
Let's wait for a few minutes. So I think let's start. Yahweh probably will join late today, and so let's start first. Jimmy, do you have? I think you have something to talk today, right?
Sean, Jim?
Yes.
Yeah, this is Harish from Infinera. I have something also regarding the HLD design, which I would like to present.
Yes.
If you want me to go first, I can go, or
yeah, you can go first.
Okay. Can Jimmy? Is Jimmy there? Is he able to hear us? Because I think he had some issues last time, and he had to call in back. So I just wanted to know if he's there as well.
I think Jimmy is here.
Oh,
you have echo, Jimmy.
Sorry, it's me. So, okay.
Hey,
yeah, I'm here. Mm-hmm.
Yeah, okay, you're there, right? Okay, and the Alibaba folks are also there. Waiting, right? I think he's there. I see that. Yeah. Okay. Let me share my. Can you guys see my screen?
I cannot.
Now?
Yes.
Yes.
Okay. Yeah. So I just wanted to touch up some on the high-level design proposal, right? So I'll just take this opportunity to present from the Infinera point of view, right? We have been having some discussion for the last 2 weeks, and we have another 2 weeks to discuss about this, right? So I thought maybe I'll just present my thought after reading the documentation and attending all the community meetings till now, right? Okay. So I'll probably give the review comments of the SONiC OTN existing HLD, and then give a design proposal for the SONiC OTN, and then we can have some questions if there is there, or maybe we could. I'll point you to the GitHub also, where I've written this document, right? Updated this document. So the idea here is basically the SONiC OTN HLD, right? It basically aligns with the existing. It has to align with the existing SONiC design and architecture. That's the main goal, so that we are able to merge it back, and at the same time don't have any issues with the existing networking SONiC as well. So that's the main goal for us to when we integrate the SONiC OTN. And looking at the design right from the beginning, right? So the design which is in which I'm proposing now is in line with what Alibaba initially presented, with some changes in it for easy maintenance and modularity. So that's where it is. So in this case, this new design, I'm creating kind of new 2 containers, one for the SONiC OTN, which basically interacts with the other containers using the Redis database for data processing and event handling. And we could create another database as well, a table like what we have currently. We have basic DB, config DB, and things like that. So if there are something specific to optical, we could probably have an optical database for storing those optical related information to be used by the two SONiC OTN containers. So that's with respect to the new containers which I'm thinking we should be having. I think if I'm not wrong, Alibaba had presented earlier in the beginning, we have an OLSS container, which is basically taking from the SWSS and then ripping off some of the things from there and then use that, right? So I'll explain on that part as well. And the last 2 bullet points here is I'm talking about the OTI objects. I think Jimmy had earlier suggested that we will put all the OTI objects and things like that in the SAI itself, and we'll try to use that. I think that's probably not the right approach because SAI is for the switch abstraction interface, which is basically for the networking. And if you combine that with OTI, which is optical, in the same side, it will probably not fly through in the OCP community, because SAI has been there by the OCP. SAI has been handled by the OCP community, Open Compute Project, whereas SONiC is in the Linux Foundation. Now there are two different organizations, and getting it to go through in the OCP community will be a tough job, I think, adding all the OTI object there. So we need to keep it separate. And I'll give you the link for the description of the design. I'll go through that also. So the way I think is, this is in the existing SONiC. I think there was a DHCP relay container, which we thought we don't need it. My guess is that probably it might be a use case for some of the customers, so it might be good to have that as well. But the TeamD container, which is probably for lag or MLAG, is probably not required. That should be fine. So the way I've organized this is have an OLSS container. If you see here, there's an OLSS container. There's an independent container for SONiC OTN, which manages only the optical related information. So we leave the existing SWSS container as is, instead of basically taking this SWSS container and then making it as an OLS container and removing some of the stuff. If you leave it like this, it becomes easier in the modularity of the design. We don't touch the existing architecture of SONiC, and we can basically leverage on this SWSS container for all the BGP related stuff or LLDP and whatever is required right from there. And we can have all the optical related information on the OLSS container doing things, whatever it is supposed to do, right? And it will also interact to the Redis. So anything with respect to SWSS updating the tables in the Redis database, if we are interested, we can subscribe to that, process that information, and then again update the Redis database with optical database or maybe any other databases which needs to be updated here, right? So that's one part of it. On the right side, if you see, I think Alibaba suggested that we use the SIND itself. I think that's probably messing around with the networking again, right? We will be probably have to do a lot of changes in the SIND to handle that. it might be better to have an optical SIND container separately, which handles that, because we are going to talk directly to the line card using the OTA APIs, right? So it will be, we will subscribe to those events in the readers and process those and then send it directly to the line card interface, right? To the line card, so that it gets processed there in the line card. So in general, this is my thought process. We're going through the different designs, what has been projected today, and trying to digest that and come up with a thing which is modular, and it's able, we can, and maintainability wise also it's easier, because we will be able to get all the latest containers from the SONiC report directly. And if you're not basically making any changes to these containers, and these will be independent containers which will be managing and for optical separately, right? So that's actually the main goal of having these two containers as new containers, which are independent entities, rather than integrating with the existing and basically trying to merge it back into SONiC, right? Okay, so that's the thing I had. Let me show you one more thing before I. So this is basically the document which I started writing, the SONiC OTN design review comments. So there's a new design diagram, the same which I showed there. So I've just explained it a little bit here as to how we can do this. And the main part which I said there, right, merging SONiC OTN parameters with SAI and SIND. I've explained here saying that SAI is an independent, SAI is another component that's maintained by OCP, which is completely different org than the SONiC Linux community, which is being maintained by Linux Foundation. So as per the earlier design session, integrating the OTN components is high. I don't think it's going to fly with the OCP community. Second, it will take time. Better to have it separate and out of SAI. Similarly, the SIND container is used for networking switch ASIC. Making a lot of changes to integrate SONiC OTN would require a lot of testing for existing functionality. It would be a good idea to have it as separate, right? So that's basically the plan. So these are the changes, the new design review comments which I wanted to share with you guys. If you have any questions, we can address it, or maybe we can put this document in for everybody else, and then we can go with the next person. I think Jimmy wanted to talk something, or Maytem wanted to talk. We can just go with that also.
Yeah, can you hear me?
Yeah, I can hear you. Go ahead.
Yeah, I think your proposal is is almost the same as what I suggest, because as you talk, the SYNC-D and the OISS is tightly coupled with the line card, optical line card. I think separate them into decouple them into a container is the best way to handle the optical logic.
Correct.
So you mentioned in the PowerPoint that the database, you want to create a new database for. Is that a new Redis instance, or just some logical?
No. I think what I was telling, that's a good point. So it's going to be the same instance. What I was thinking is, I just need to think a little bit more on that as well. I was thinking, but I just came up with that because if we have any specific optical parameters, right, which basically doesn't fit into any of these other databases like config DB or anywhere, right? Then we can create an optical database and put it there, is what I was thinking. That's my thought process, right? In that case, creating another database. So it's not an instance. It will be like your config DB or ASIC DB, another table or something like that. It's not an instance.
So the problem is that the message flow, or the configuration flow, is that we have to use the config DB, state DB, flex DB, history on this. So we should, I think you propose that we should reuse this config DB, but you want to create another two logical instance for the optical data. Is that correct?
Okay, so you're bringing, so yeah, for the configuration in anything which comes from the Northbound or through the CLI, it will go through the config DB. We will be subscribing the optical line card switch state manage container, or whatever we call it. It will be subscribing to all those events for optical related stuff, right? And then process that. And I think, and what I was saying is post processing of those events, if there is anything to be sent to the line card, right? So you don't want to put that in ASIC DB. You could put it in an optical database, which can be consumed by the optical SYNC D is what I'm saying.
You want to replace the ASIC DB?
No, not replace. That's what I'm saying. Okay. So what your thought process with Alibaba was like, you were replacing the SWSs also, and then you are adding things into the ASIC DB, right? That was your idea. I use the same SYNC D. But my thought process is different. I'm saying the existing architecture of SONiC will be as is. We are not touching any of those. If you need to enhance the existing databases to accommodate the optical information in config DB and things, that we will do that. Other than that, we will use another optical database table, which will basically be used only by the optical OLSS container, which publishes that into that, and it will be used by the optical SYNC container on the right side of the readers, which will be consuming that and then sending it to the line card using the OTI interface to the line card. That's what I'm saying.
This Harash, this Jimmy here, this is already being done in ASIC DB, right? Although the name is ASIC DB, but pretty much that's what
No.
DB
See,
function you are talking about. Yeah.
Jimmy,
In current implementation, I say.
No, Jimmy, what I'm saying is like ASIC DB, right? Is using, ASIC DB is getting used by SI and SYNC D, correct? For switch programming.
Yes.
Correct. I'm saying we will not put any optical related stuff in the ASIC DB, or we will not extend SI. We will have OTI.
Now it is in the current implementation.
No, that's what I'm saying. That's my change. That's what I'm saying. That is my change.
Oh, you wanna be don't touch,
exactly.
Don't use the current ASIC DB. Basically,
exactly.
Another DB. Okay.
Exactly. Exactly. That's what I'm saying. So the way it's being, the way I am like showing, if you do it like this, it becomes independent entities. And when you go back to merge with SONiC, it becomes easier for you because your optical entities are all separate and you won't have any conflicts. And the second thing is you will not be breaking any existing change in case, right? If we have to run a lot of tests and everything in SONiC existing networking as well, if you're basically integrating with the SI, with the ASIC DB and making changes to SYNC D and things like that, right? That's what I'm saying. We can probably make it separate entities so that it becomes cleaner, modular, maintainability is easier, and merging back to SONiC is also easier. And we follow the SONiC architecture as well, is what I'm saying.
Okay, I understand.
I think if we can reuse the config DB or the state DB as with the IP routers, why not we can reuse the ASIC DB as well? That's my question. Yeah.
No, ASIC DB, I mean, the ASIC DB is tied up with SI today, right? And it's for the networking, most of the thing. If you want to, I don't want to overload things in one. So if you just make it modular, it becomes easier for maintainability, and any issues also will be able to figure out easily. And by making this change, you have to basically go and make the change in the schema for ASIC DB and everything also, right? You have to change. So you don't need to change all those things. You can keep it separate so that it doesn't interact with the existing functionality of networking, and you won't see any breakage. I mean, we introduce something, and if you break, then we have to go fix it, and then we have to do all these things, right? So that is not, that we are probably avoiding, right, by doing it more modular.
Harash, yeah, you like logically that makes sense. However, for this particular implementation, right? Once we change the OLSS container, like SWS become OLSS, and also on the other side, we change the SYNC D, then ASIC DB, it is just the pipe. So all this data and everything is automatic generally. Okay. Yeah. So you really don't. So if you change the name of the database, it's okay too. But
no.
It's really
that's what I'm saying. I'm not going that route, Jimmy. Jimmy,
Okay.
I'm repeating once again. I'm not taking that route of renaming SWSS container to OLSS. I'm
I
not
see.
doing that. In this architecture, you will have all because you need SWSS for networking, right? For BGP,
Yes.
So why do you want to put optical there? Is what my question is. You leave it as is.
Oh, okay.
You are
You
having
have
all
another
these
container,
containers.
parallel
Sorry?
running, 2 containers.
Exactly.
the-
There are going to be 2 new containers. That's what I'm saying.
2 additional container, basically.
Exactly.
Okay. Okay. Understand.
That's what. So that way you keep everything optical in one place. You're not confusing things. So if you change SWSS name to OLSS and you put in your code there, the chances of you running into issues with networking is more.
Yes.
I don't want to do that. I am
Mm.
delimiting these 2 things completely separately, right?
Okay.
So that everything is an independent entity, and you get the exactly whatever you're getting today in SONiC networking. You get that on top of it. You're adding these 2 containers, which are basically managing your optical. And
I see.
if you need something, if you're basically interested in anything with what SWSS container is publishing, they go on publishing OLSS as well to the radius, and you get the information. We process that information. You don't need to basically add any code into SWSS. Similar is the case with SINCD. I'll give you an example of current SINCD, and you'll understand why I'm doing this. Okay, if I just take an example, right? Let me take a use case of port down event, right? So if the laser goes down in a networking, if the laser goes down or something, right? The port down event, the moment it goes down, the port down event comes to be through the ASIC DB, it basically comes back to SINCD. And SINCD is the only one which basically puts the port status down, and it will inform, it will update the radius and ARC agent and everything. It goes to all the application. But now the way we have to, in our case, it's an optical interface which is in the line card. So we need to manage that. How do you basically manage that with SINCD and things like that? So you need to make changes there to update SINCD and all these things. By doing it the way I am doing, what will happen is you will get the intimation from the line card for port down event to the optical SINCD container, and then you can probably update the radius, or there needs to be some information, some method of basically telling SINCD, okay, the port is down now. So that's the way I'm saying, instead of basically going and changing the way SINCD itself is doing and a lot of changes there, that'll be a lot of effort, and we'll be doing a lot of testing. So this is kind of making segregation. You're basically putting a demarcation about the different boundaries for all these guys, and everybody is independent. So you don't have to worry about bugs and things like that, which will be less.
That's it. So in this design, Harash, just let me confirm. So even for optical device, original SWSS and the SINCD are still running, right?
Correct.
Okay.
You're right.
Okay.
Exactly. Yes.
So Harish, basically this one is the addition to the existing SONiC system or architecture, right?
Give me a second. Who's asking?
Hey, this is Songjin. So I'm asking.
Oh, Songjin. Yeah. Go ahead.
So your suggestion here is that this is addition to the existing SONiC system.
Correct. Yeah. If you see this, right, this is what I said, right? I said we'll be adding 2 new containers. Right?
Add 2 new containers without removing any existing container.
Exactly.
Okay.
So that way it's a cleaner approach. We are following the initial design, but there is changes to the initial design. We are in line with what Alibaba's thought initially, but we will probably change it and make it more modular, maintainable, easy to push back to the SONiC community, and we will have less less issues facing down the line as well, right? And keeping the OTI objects and SAI all completely everything independent, right?
Another thing I want to add is that if this approach also provide the possibility to support both, right, at the same time. So like
say it again one more time. I didn't. Can you repeat?
So this approach also provide the possibility to achieve both at the same time. For example, a combined box, optical packet box.
Correct. Exactly. Exactly. Yes. Yeah. That you'll be able to get that also, right? So that's my thought process. That's what I wanted to give. Yeah, a lot of good questions. Yeah, so Harish, I have not, I created a repo. If you see here, it just created a repo. I'll make it public. I'll just push these changes there. And yeah, we can get more comments. We still have 2 more weeks. for discussion, so we can just come up with any questions also. I can answer that. Any other questions?
Yeah, I had one question. This is Sandeep. So, so when we have ORC agent and SYNCD, and we don't have a corresponding ASIC in the system, so how are they going to run actually? Because for any of these initialization of SYNCD, you need to have an underlying ASIC, which means in this case, if you don't have the ASIC, you have to modify the SYNCD code to boot up. Right? In the absence of ASIC, SYNCD will not come up, right?
No, you will have a Broadcom chipset in your controller card also, right? Which you will be using, right? But that will not be for optical.
Okay.
But you will be using for other purposes, right? You have DC and other things as well, right?
You mean ASIC of? So I was not clear of that part. That when we say a combined box, the combined box has both the optical devices.
No, don't worry.
Well as
combined box is another option which Jimmy said. We'll think about it. But my part here is the main idea here is not to disturb the existing architecture and have the optical separated out independently, so that you build the optical and put it in there. You will basically have the optical interfaces going, right? The optical working separately without any issues.
Yeah, to answer this question, my initial thought would be like when we implement the O-type driver, right? We can have a dummy like a PSI driver. So because in the pure optical device, you don't use them, but you still can have a null function to register, right?
Correct. Yeah,
so
you
this
could do
will this will let your SYNCD come up.
Yeah, you could
so
do
we
that
will
as
have a
well.
dummy. Okay.
Yeah, you can do that.
Yeah, you can have a dummy. So,
so basically, the way it works is, right, SONiC, I think when it comes up, right, there's a hardware SKU for each of those hardware, right? It reads the hardware SKU, and you have all those port mapping and everything for SYNCD. There's a port.ini and things like that. It has all those information for lane configuration and things like that. Everything is there. If it is there, it'll basically pick up that and it'll initialize. Otherwise, it'll probably skip.
Then in the real hybrid box, it will be a Broadcom SYNCD, right? So for example, but in pure optical device, we need to make some dummy probably driver for SYNCD.
Yeah, we can get to the detail. We can get to those details. We can just look at that. But I mean, this is just my general concept on the design of the HLD now.
Yeah, I want to add a comment that maybe we don't need a dummy SYNCD for the PSI, because if we make a platform for the optical device, we can just disable the SWSS and the SYNCD. That in this system we only run the OLSS and the optical SYNCD.
No, wait, tell me one thing. You will be using BGP container, right?
Yes, that's right.
Okay, so if you're using BGP container, so then how do you basically communicate all those details, right? So you will be using only SWSS in that. So that's the reason I'm saying we will not disturb the existing architecture. So it will be done using the SWSS container. ORC agent will be involved. BGP container will be involved. And you will, if there is something needs to be programmed in the ASIC, probably the ASIC also will be involved in that, right? So you leave it like that.
Yeah, probably LLDP too. Probably LLDP too. I'm not sure.
Sorry, go ahead.
No. I just say on the same line. Probably LLDP will need the current SYNCD as well. SWSS container.
Correct, SWSS. So that's what I'm saying. I'm leaving the networking part as is, not touching it, so that we are not basically mucking around with the SWSS container. It functions as is. So it's like a networking, whatever it needs to be do, it's doing. We are not shoving in the optical into that. We are taking it out of that picture and making it a separate container so that it becomes easy for maintainability again, right? That's the reason I'm just saying this. And that's, so if we do it like this, it becomes easy for maintainability and everything, right? And optical is separate. There won't be any confusion, and things will be flowing in the right way. And we are actually following the same architecture as what SONiC is today. We are adding on top of it new things, and while merging it back, it becomes even more easier as well now, right?
Yeah. So actually, in an optical transport device, or in Alibaba's device, we can run the BGP container and LLDP container without the SWSS, because we don't have an ASIC or a router in our hardware. We just because we use the Linux kernel to do the routing things. So
right.
I think okay to remove the SWSS, just to keep the BGP or the LLDP. I think is fine. So maybe we don't need to keep both, but if it's a practical optical device, maybe we can keep both.
Yeah, so that's what I'm saying. It is better. So you don't want to have multiple designs here. You have a design which caters to the needs of all the different use cases for you, right? That way you don't have to worry about things. Otherwise, you need to again make this change again, make it to enable and things like that, right? So that's what we are in a futuristic path. If you just think, if you make it enabled by default, you are taking care of the second scenario, which is that even the packet, right? Packet plus optical is taken care of here, right?
Okay, that makes sense. Okay.
Yeah, so that's one thing. And the other thing, yeah. So what you're saying is you're using you're basically using the Linux netlink, right, for the BGP, right? All the routes, everything is coming through that, and you're programming through that is what you're saying, correct? From the BGP container.
That's right.
Okay, so you're using the netlink directly. So you don't need because you don't have an ASIC. So if you have an ASIC, yeah, then it will basically go through the radius and it will get published to the ASIC as well through the SINC-D. So that's another option if they wanted to do it as well. Yeah, so this was my proposal. If you guys have any questions, we will go forward, or else we can switch to somebody else. Is Yahweh there now?
I think Yahweh.
Yeah, I think Hari,
Yes, yes,
I have
I'm
one
here.
last
Okay,
comment.
join.
Yeah, sorry.
Yeah, go ahead, please.
Hari, yeah. So I think in the absence of an ASIC, we may not really need to run SWSS and SINC-D. However, if we still want to keep them up and running, we may have to clearly tell what role they will play in the absence of an ASIC.
Yeah.
Otherwise, the community might ask this question as to why you want to run it if they're not going to be used in the absence of an ASIC.
Yeah, we could give all the different use cases, right? And then we can just go from there, right? So that should not be a problem. So at least, right, when you talk to the community, you are not making a lot of changes in the SONiC networking itself.
Yeah.
Now, right? So that
Exactly.
that gives you a first green path, right? Okay, these guys have not touched my code much, man. So it should be easy for them to go in as well, right? So that way, it's alleviating all the issues, right, which we think we might be facing, right, while going in.
Yeah, the minimal we keep it. Yeah, it's
Correct.
the best.
That's actually my idea. So that's the reason I just came up with this. So probably this cater to the needs, and we can come up with those other questions which you have or Weitang has, right? So maybe we can address those as well, saying that how we'll handle these cases, other scenarios.
Yeah, sure. Thanks.
Yeah, that's all I had. Let me stop. Anybody any more questions before I stop sharing? Going once, twice.
Was there a question for me?
No. Oh, Yahweh, I was just asking, do you have any questions in this new architecture diagram which I am presenting?
Well, I joined late. I'm sorry for that, but I may need to go back and check the video recording before I can answer that.
Okay, I can quickly share just a couple of minutes. I'll just share. This is the proposal I'm just putting. Basically, comments about the OTN existing and the design proposal for SONiC OTN. The things which I'm doing are here. I can probably upload this to the SONiC OTN group as well. So the way I'm doing is currently it's in line with the existing SONiC design and architecture, and it's in line with the initial Alibaba's proposal for having a OLSS, but slightly changed in the way I'm doing things and the way it was done earlier. With respect to both the SINC-D as well as the OLSS, we're creating 2 new containers and then using Redis database, other table for optical to handle any optical related stuff. And the other main thing I'm talking about here is not merging the OTI objects into the SI. That will be a real nightmare for us talking to OCP community, which is a completely different org than the Linux Foundation where SONiC is. So that has Broadcom and Juniper and Cisco and everybody is there in that also, right? So If you're just combining everything into psi, it'll become a lot more. You have to go through them a lot more cycles to basically make it work. So it might be better to have it as independent entities, is what I was saying. So these are the main thing. And then I showed you this diagram. So which I wrote. I'll probably give this link also to you.
Okay, thanks. I think at least the part that is keeping OTI separate from psi, every one of us here are aligned, right? So no one was trying to push OTI into psi, I guess.
No, I think there was a suggestion where we add all the OTI into the psi header files. Is that right? Jimmy was suggesting that, if I'm not wrong, last week before last.
Jimmy was suggesting that?
I think, right, Jimmy?
Uh,
Are you right?
Jimmy, yeah, Jimmy will suggest that. Yeah, talk about this later.
Yeah, so there's a two sides about this. One is the specification, right? OTA is totally independent. Then the implementation as well, right? The
Correct.
coding and everything, that's clear. So what I try to say is that at the runtime, okay? So this OTI object and also API group, it will be just add at the end of the psi, current psi object. So the idea is you don't need to even change syncd and the SWSS as is, no change, then it will work. So that is my idea. But the Harash has a point too. So to kind of eliminate the interference with current switching product, right? We should have everything separate.
Right.
So 2 additional container, which makes sense too. So yeah.
Right.
So
yeah.
I don't know if it is this explained. So spec, coding, of course, header file, everything is independent, right? But in the compile time, we can make it because they use metadata, right? To auto-generate all these objects. So we can actually attach them at the end of this psi object and the APIs.
Yeah, but you have to go through the review process with the OCP community, right?
No, you don't. Psi is as is, right? So we, at the compile time, we just expanded the psi with the structure with our OTI object. So yeah, we can talk about this.
Yeah, we'll talk about it. Yeah, anyway.
That's some ideas, but this.
Sure. Yeah.
Yeah.
Okay, thanks, guys.
Okay. Yeah, thank you. Maybe now we have 3 HLD, right? So Jimmy's proposal, Alibaba's proposal, and Infinera's proposal, right?
I think you're going to talk, right? I think Yahweh, probably Jimmy is going to present something, right?
I have one thing is about like now next thing we need to do. We have 2 things, right? One is the HLD, which we are discussing, and the second is the OTI spec, right? OTI spec. So if we have time, I can talk about it. If not, then we can talk about next time. So we want to review the existing Alibaba's OTI spec, and we will collect some feedbacks. So, and make the final, then publish, right?
Yeah, I think probably you talk about first, then we discuss this later.
Okay.
Just get all the ideas out.
Sure. So let me share.
Yeah, I think my comment was just we have 3 HLDs. We need to get a line among ourselves, right? So before we're proposing it back to the SONiC community and get it merged. And also, creating a new repo is another pending task. But in order for us to really decide on HLDs, I think this kind of discussion of some of the details, especially OTI, will be necessary, right? So the details can also tell the architecture how we should architecture it. Okay, let's go ahead, and maybe if time is not allowed, we can use next time or even propose a ad hoc meeting with key members of availability to discuss HLDs to try to get aligned among ourselves.
Okay, so I just go this quickly. We can always have like an additional meeting or offline to communicate, right? So this feedback from existing OTI API, we Molex team had an internal discussion. Then so far we have like two feedbacks. Okay. First feedback is that all this manufacturing inventory information and the generic operation, which is already implemented in the current PMOND, we should not include in the OTI. So OTI, if you follow the SI convention, the SI is only packet switching functionality, nothing to do with hardware, right? So OTI should be the same. So we deal with the optical services and the features functionality. OTI does not deal with any hardware and generic features. So that's one. So actually this diagram, I think I presented before. So there's a very clear demarcation on the functional scope of current SI and the PMOND, right? So we should follow the same convention. So that is the first one, right? For example, in OTI, we have like a manufacturer name, all these attributes. I don't think we should be in the OTI. They are already currently supported in the PMOND platform, right? So, and the second is the generic operation. Like these are nothing to do with optical traffic. So the line is really clear. You think, is this to do with any optical feature? If no, then it should not be in OTI, right? So for example, the main state operation, state removal, empty, upgrade, reset, those are already implemented in the platform-based classes. So what we need to do is just add a subclass for each specific device. So that is the first comment. Second comment is, right now we use a line card as a top level object, which is fine, but the name, I kind of have some issue with that. So line card is not really a kind of abstract thing. It's an implementation mechanism of a box, right? So some optical device may not have line card, or some optical device can consist of many physical chassis, right? So why you use line card as a top level object? So that is the issue I think we probably should think about. So I put like two options. One is just the top level option inheritance switch object from side. So we will call it a switch, but also now switch here in the SONiC world, it's actually extended to cover optical device as well. One example here is there's an ongoing Dash project. So what they are doing is, for example, Dash project, they support appliances, right? These appliances are not really switch. They are a bunch of DPU, data processing unit, and put it together. It is more like a server. So, but they still use, they are not changing the SWSS, right? Still use switch as a top level object. However, there's a device metadata that you can specify. For example, this is the appliances subtype, right? So here we can say this is the OTN box, and all these things we can use at the compile time as well as at the runtime. So to distinguish what piece of code you want to activate. So SONiC did a really a good job on these abstractions. So I hope we can use. Now, of course, the switch name, the face meaning is different now, right? So, but the Dash is already doing that. Switch is not only switch anymore, it is appliances server. So, second, if this people think this is not a good side, will cause some confusion, then second option I propose here is use a module as top level object, right? This follows TIE. tie actually the transponder box, they call it a module. And then there's host interface, then also network interface, just the three kind of object, which is very, very high level abstract. So the module name, like now, again, in a multi-ASIC architecture, like implemented by Ali team, the module can be a line card, actually, right? So this is exactly what the PMON do. PMON define the module, has a three type: line card, supervisor card, and the fabric card. So top level, instead of using line card, we can use a module, which is a more flexible in semantics, like syntax, they're called a module, but what does it really mean? It has more flexibility, right? So in the single ASIC architecture, module can be optical device itself, right? So yeah, we in like our project, one of our project, we say, okay, this is an AMP module. AMP module really is a box. So module, and of course, any other other term is welcome. And I just don't think the line card is a good one for the top level object. Yeah, that's all I have. Those two things. So I will submit this as well into the our document repo. So anyone can have a comment or write another thought. Yeah, so people can read it. So that's all I have. Any questions, comments?
Hey, Jimmy, I have a couple questions.
Okay.
And first is that the module, the module is that I think the system can be just a pizza box, right? Everything just embedded, probably just one motherboard, everything on the motherboard. The second option is that you can the system or the box have a few pluggable probably slots. And the slot can, for example, the one slot can contain amplifier and coherent transponders. So in that case, and module probably it's not a good way to describe that.
Yeah.
I don't know. So is there a better way to describe this kind of things? So that's my first comment. The second comment is that if in that case you have a slot, you can plug in different function. You can call modules or line card. Then each of these line card, there's contains some of this general information, and so these are like a multi-chassis system. So in that case, I'm not sure if you don't include that generic information inside that slot, and where are I going to put that? So that's
yeah. So for the second, so this question actually, I don't have, let me see if I can find it. So in PMOD actually is exactly provide all these, the hierarchy from chassis, right? So how many modules? Chassis is a chassis. So module is a line card. Then in the line card is a component. So these are three levels. It's there, there's a JSON file you can define. So it's very convenient to describe what the device hierarchy looks like. Yeah.
okay.
So, let me see if I can find it. The hold on a second. SONiC. Right. So we have a SONiC. No, it's nothing in this. I think it's in the doc.
Hey, Jimmy.
Yes.
Okay, you got it up.
Yeah,
you can
so,
actually
so
search for the
here is,
JSON.
is what the SONiC, this platform hierarchy support, right? So you can look at it, the chassis has a module. Module is a line card, a supervisor card, and the fabric card. Then each has a component. So EDFA and WSS OTDR is really a component inside the module. That's how it defines. Yeah.
Okay.
So this is actually a JSON file loaded by a platform daemon at the start. So you know exactly what is this box looks like. Now, if you plug a new line card, then this structure will change. Okay. Of course, you need to write a code to reflect that. Yeah. So
okay.
That is, so all these things. I mean, the issue we have is if we have all these in the OTI, then people will challenge us, right? So I already did this in the PMON-D SONiC platform. Why you want to put it in the OTI? So.
Jimmy, this is Lee from SONiC. So about this topic, I do have a question. So why I explain one reason why we didn't choose PMON to do this kind of module control in this part. If you go back down to the page when you show the PMON to control all the modules, so you can see if you look at all the sensors, LEDs, it seems so all of these modules are sort of independent from each other. For example, you don't care about whether the front panel LED and the status LED, which turn on first, which is off, and you just need to check the status. But when we do optical line card control, actually optical line card is sort of the interop with each other. For example, if we control one amplifier card, we do care the sequence on which card we operate first. So when it's a complicated operation, especially coming to the interop and the sequence of each line card, it is very hard to cover all this kind of complicated functions by PMON in this part. So if we get back to the OTI, it's more like powerful, like we control all the switch chips like the ASIC, that we can add more complicated interop, especially with the database in this part.
Yeah, that's a valid question. However, you should enhance this PMON-D instead of putting in the OTI. That is the point.
Yeah,
right?
If you go back to the PMON-D, basically that's the communication interface like through the EEPROM visit or EEPROM like interrupt with each other. It is not really real time, which to control the line card or like functional parts in like PMON, because it's very slow to interrupt with EEPROM. Like that.
Yeah, well, we can look at the detail. First of all, this document is not up to date. So you want to see exactly what the feature PMON-D support, you need to look at the code. For example, there's a software upgrade, there's a reset, all those, right? Watchdog. Second is that these basic, so what is your question again? I kind of lost.
It's like we do care about the real time of the line card control, and also the sequence and interop between different line cards. Yeah,
I see. So those may be, I would think, is a common question for SONiC packet switch, right? So how do they deal with? I don't see any special thing for the optical. The optical from a real-time point of view has much less requirement to lose than a packet switching, I would think, which is more dynamic. So I don't know how we can do something. What I mean is this is a problem should be already solved. Yeah,
Yeah, this OTI. If you come back to OTI, rather than PMON, OTI is sort of more powerful than PMON. OTI is we can say that OTI is something similar to the SI in the original SONiC architecture. So we just make a new branch, like something in parallel with the SI. We call it OTI, or previously we called it LIAT to indicate the line card. Actually, yeah, I agree with you that the name of the line card is sort of limiting the cover range, like because you mentioned that the form factor of the pizza box, which could not be covered by the name of the line card. But come back to the optical like functionality like that. So we think that OTI, which is more similar to SI, is more suitable to use to control all the optical functions like the amplifiers, like that.
Except these things, right? So so they are covered in the platform.
Yeah, I agree.
Already, so so that's my feedback.
Yeah, so I see why we use the OTI to control this. I agree. This kind of information is sort of static rather than real-time changing. When we come back to how we talk to the optical line card, like physically, physically just through the same channel, like Ethernet interface to talk to this line card. We don't have a separate like EEPROM to talk to this line card, especially come back to the pizza box form factor. You only have one Ethernet to talk to it. No matter the command is to query the manufacturer name, or the command is to control the gain of the amplifier. So that is why that we bundle all this static information together with all that active control together to make all the information to OTI.
So I have a recommendation for that, because the OTI driver, right, underneath it will be the same driver of the platform driver at the bottom. You understand what I'm saying?
Yeah,
so that's our implementation. So there's a HAL, basically hardware abstraction layer. So either you from this way or you from that way. Actually, selectively, you can do anything you want to. But to follow the SONiC structure, you need to go the correct path. That's what I try to say, right? So as you say, the common path is really achievable because you have a shared library here. So I don't think any problem to talk to. You don't have to everything go to OTI. That's the point. Yeah. So you this driver this driver is very capable, same as the optical driver. So it's just for the structure. Yeah. So that's what we are proposing. So you have one shared library which can be used by both sides, basically. Yeah.
Okay, let us discuss internally.
Sure.
Part, whether it is visible. Yeah, thank you for your comment. I got your point.
Okay. That's all I have.
So also back to the option 2 about your comments in issue 2.
Okay.
I think this one is something similar as the first one, is that we use PMON less than OTI. Yes, I think that.
Yeah. So the line card has 2 aspects. One is they contain many optical components, right? SWS, EDFA, those should be the
on this point. Yeah. So
but the line card has line card has also a generic aspect, like a plug in, plug out, upper grade and reset. Those currently are managed by PMON. So that's what the current
you suggest lots of PMON. Yeah, that's just as you mentioned, that why we use PMON less is to think concern about the function limitation on the PMON.
Yeah, exactly. But you can always, that's a separate topic. So we start with the optical feature, right? So we should enhance PMON, which is also okay, but we should not kind of change the role of these two play in the SONiC architecture. That's the point. Yeah,
We
certainly.
got your point. Yeah.
Okay.
I think we should define. We can
Okay.
define
Okay.
this
Thank you for your comment.
attribute in the OTI,
Mhm.
but how we extract this functionality in OISS or in PMA, I think that's an open question, right? We can
Yeah,
define
some are
this.
easy. Some are easy. Like this should be in PMA, in my mind, really clear, right? Now, and the main upgrade, you say, oh, it is more complicated. We need the OTI driver to do that, right? But it's okay. But you still can do it from platform driver, which will call the same shared library. That's one implementation, right? You don't have to distinguish. Yeah. So in our prototype, we actually have a driver common one here called the hardware abstraction layer library, and both can access. So it's a shared library. So we load from here to here. So then you have a freedom to move anything between the two. So yeah.
Yeah, so this is Matthew from Infinera. I just joined this forum starting this week. I tend to agree with Jimmy after reviewing the OTI specs myself. I think it's mixing a lot of things in the OTI spec. Things like equipment information, reading inventory information, manufacturing data, that sort of stuff really, I believe belongs on the PMON side. In terms of initiating an upgrade to the line card, I think also can be done from the PMON side, but the orchestration of how components within the card get upgraded, that can be left up to the specific line card implementation, right? So I tend to, having just quickly reviewed, I just got on this project, right? But having quickly reviewed the OTI spec, it does, the proposal, it does seem to mix a lot of things that in my opinion, also do not belong together. I understand what Lee said about why it was done that way, so we do need to investigate that, right? The concerns that Lee brought up about potential real-time concerns and things like that. But in terms of just purely separating functions, right, in the right place, I tend to agree with Jimmy on the on his concern as well. I was going to raise the exact same thing when I got a chance to speak.
Yeah, quick comment from me. First, welcome new members joining the forum, right? We do need more opinions and contributions. One principle I want to say is let's try not to reinvent the wheel as much as possible, right? So for whatever is already defined in SONiC, if it can be reused, we should try reuse it as much as possible. That applies to like the serial number stuff. What I'm thinking is why we should redefine it if it's already there, right? So yeah, so of course concerns should also be accommodated, but try not to reinvent the wheel because we are inheriting from a SONiC project, not really creating a new project. That's one. Number two, on the issues, naming of the high level, top level object, right? So this one, I think I heard all the points, discussing points. One additional point I want to bring is sound like the module naming aligns with what OpenConfig is already defining. As if the data model, this is more like defining a data model of what contains what. Then OpenConfig actually already did a job. It's the high level transponder is defined as a module, right? So protection switch is defined as a module. Wavelength router is defined as a module. Those things, if we are trying to reuse OpenConfig models as much as possible, of course, if there's conflict, we already said if there's a conflict in naming, we follow more of a SONiC naming convention. But if there's no conflict, then we can also try to reuse. That's what's already there in OpenConfig, right? So I kind of prefer option 2 here, as module is already used in the other naming convention that is open config. It sounds like it's not conflicting with any existing SONiC naming convention. And the switch option 1 using switch as a high level object name is a bit misleading, right? So although the Dash project is already doing it that way, but SONiC, the OTN stuff, most optical people understand it's not a switch. It's not doing anything close to a switch. The Dash server may sound like a appliance server, or also in the switching world, right? So you may need some appliance server to do some specific maybe firewall stuff or other stuff, but OTN is a completely new, different world, right? So defining OTN stuff as a switch is a bit misleading to me. So I prefer module better.
Yeah, I agree with you. I think that module is a better way to go. I think the less translation we need to do between OpenConfig and the hardware layer, the better off we're going to be. And it's also less effort on our part too, in terms of actually implementing it, right? So if we can align with OpenConfig names as much as possible, since that's going to be our NBI model, right, that we're going to be dealing with, I think it also helps with the understanding and readability as well.
Yeah, agree. And I think at least the implementation I see, like SONiC Alice implementation was trying to borrow from OpenConfig as well, right? So
yes, yeah,
as much as possible.
exactly.
Yeah,
Yep, I saw that too. Yeah. I think most of it, I think it's looks good. I mean, I think there was kind of these top level equipment level things that were in there that was, as Jimmy mentioned, right, that we probably need to kind of clean up and separate out.
One question here. So if we use a module to replace line card, then for each module there may be transponders and amplifiers. So you use components for that transponders and amplifiers, other components. Is that correct?
From PIMA point of view, yes, that is correct.
Yeah, I mean, it looks like, every module could have components, right?
Components, yeah.
Every module can also have subslots or SFPs or cages as SFPs, I think they call it in the spec that Jimmy flashed, but each of those can have sub modules, right? Where you can plug in amplifier or EDFA or an OCM, whatever, right? And then, and that in itself also becomes a component, right? And then you could get really nested, right? You could have a pluggable in a pluggable sometimes, right? I mean, you can have that too, right? So, so it actually becomes kind of nested recursive, right? But in the end, it's all a module, right?
If Chongjin, if you look at the OpenConfig platform.young, right? So everything is component actually, right? So top level is a module, then component can be anything. So component can contain another component. So, but in the PIMA, it's more like a 3-layer. It's more kind of harder defined. Chassis, module, and the component. Yeah.
Okay, yeah. So make sure that the module can have multiple different functional or submodules or components.
Yeah. So we should follow SONiC as we work in the SONiC group, right? So module, they say it's a module. So then EDFA, SWSS, WSS, sorry, OTDR is a component. Yeah.
Okay. I think we are running out of time. Yeah, it's a very good discussions.
Yeah, very good discussion. Okay, maybe we follow up in emails and
yeah,
then...
we follow up emails. Then we stop today, and if necessary, probably have a additional meeting before next one, or we just communicate by email.
Absolutely.
Sounds good.
All right.
All right. Thank you.
Thank you.
All right, thank you, everyone.
Bye-bye.